Hello, this is Mr. Stansbury. I'm going to take you through the 9K notes on where functions meet. At the end of this, you should be able to say that I can find the intersection points of quadratic and linear functions. All right, so let's talk about the possible intersection points. So if you have a quadratic and a linear function, they can intersect in one of the three possible ways. So they can be cutting, which would have two intersection points. They can be touching, which would have just one intersection point. And then they can also have, so there's the two intersection points, there's the one intersection point, and it also can be missing where there's no points of intersection at all. Okay, so let's take a look at an example. And the first one we're going to look at is example 33 from page 308. Find the coordinates of the points of intersection of the graphs with the equations y equals x squared minus x minus 18 and y equals x minus 3. So now what we really want to do is we want to figure out where these graphs have the exact same coordinates. So what we want to do is just set them equal to each other. So we can say, when does x squared minus x minus 18, when does that equal x minus 3? So since we have x squared, x's, and constants, I'm going to move everything to one side and try to factor it. So I'm going to move everything to the left side since my x squared is already positive. So when we do that, we get x squared minus 2x minus 15 equals 0. So we want to hopefully be able to factor this and say, what are the factors of 15, which are 1 and 15, or 3 and 5, that have a difference of 2. So that doesn't, 1 and 15 doesn't fit the bill, but 3 and 5 do. So we say x and x, 3 and 5. This sign here always goes with the larger of the two factors, and then this sign here tells us that the signs are opposite, so it's x plus 3, x minus 5. And we know that this has got to equal not 6, but 0. All right, so x has to equal negative 3 or positive 5. So since there's two possible answers here, that means we're going to probably have, well, we're going to have two intersection points. Okay, so this is going to be the cutting example that we saw first. So let's go through and figure out what those, these are the two x coordinates, so let's find the y coordinates. So since we have the x's, we can plug it into the x's into either one of these two equations to figure out what the y is. So I like this one a lot better than this one. It'll just be a little bit easier, so let's do that. X equals negative 3. So if x equals negative 3, we would say y equals negative 3 minus 3. So the y coordinate would be negative 6. So one intersection point is going to be negative 3, negative 6. And again, we know that there is a second intersection point when x equals 5. So we do y equals 5 minus 3. So y is going to equal 2. So the other intersection point is negative, oops, sorry, not negative, that's the first intersection point we have is 5 and 2. All right, so our 2 points of intersection are negative 3, negative 6, and 5, 2. All right, let's take a look at another example. Okay, and that is example 33b. This is like number 2 on page 309. It says, find the coordinates of the points of intersection of the graphs with equations y equals negative x squared plus 3x minus 5 and y equals 2x plus 3. You'll notice in the directions it says use a graphing calculator to figure that out. So here's what we're going to start with. Let's do negative x squared, just like what we did before. We're going to set the two equations equal to each other. And then we're going to move everything to one side. Now, we have a negative x squared over here, so I'm going to actually move all of these to the right side so that we get a positive x squared. It just makes it a little bit nicer to try to factor. So let's add x squared, subtract 3x, and add 5 to both sides. All right, so we get 0 equals x squared, 2x minus 3x is negative x, and 3 plus 5 gives us 8. Now you say, what are the factors of 8 that add up to negative 1? There aren't any. So you can't actually factor this out. So we can do a couple different things. We could enter this into the quadratic formula and solve it, or we can actually do what they are asking us to do, and we can plug it into the graphing calculator and see what we get. Okay, so first thing you want to do is clear anything out that's already in there, and then we're going to enter in these two equations. So make sure you use this sign here instead of the subtraction. Use the little negative sign whenever they're giving you a negative value. So negative x squared plus 3x minus 5 for the first one, and then the second one is 2x plus 3. Okay, and when we go to graph this, it should show us what kind of intersection points we're looking at. So there's the first one. There's our y equals negative x squared plus 3x minus 5, and then there's y equals 2x plus 3. And this one here is going to give us no intersection points. So find the coordinates of the point of intersection. No intersection points. Okay, so that would actually finish you off for this problem here. Okay, so now let's actually go through and figure out what would happen if this here actually, if these two equations would actually intersect with each other. So I'm going to change this 2x plus 3 into, I'm going to change that to 2x minus 7 to see if I can actually get them to intersect a little bit, well, at all. So if we do 2x minus 7, aha, we've got 2 points of intersection. So again, not really easy to look at that and figure out what the points of intersection are, but you can actually calculate this on the graphing calculator. What you do is you do second and then trace, which up above says calculate, and we want to find out where they intersect. So we go down to 5, we hit enter, and it's going to ask you here, first curve. This is on the quadratic, and you just say, sure, yeah, that's the first curve we want to look at, and then it's going to jump to the other line here and say second curve. It's not a curve, it's a line, but we'll say yes. And so what it's going to do is it's actually going to find the intersection points, the intersection point of these two graphs, the nearest one to these 2 points. So it's probably going to find this one over here to the left first. So let's take a look. Push enter, and it's going to give you this little x right here, and it just so happened to be at -1, -9. So if we turn this into y equals 2x minus 7, and this one over here we get, what did we get here? We got -1, -9. Okay, and then we can actually go through and find the other one as well. So we do second calculate, and go back down to intersect again. And now all we have to do is just scroll over until we get closer to the other point of intersection. So I'm going to get closer to that one, and I'm going to push enter for the first curve. It's going to jump straight down to the other one, second curve. Yep. Guess, sure, why not? Let's guess, and it should give us this intersection point here, which is at 2 and -3. Okay, so that's a way that you can find the intersection point, the intersection points with the graphing calculator. Okay, so that's really all there is for this. If you have any questions, feel free to ask, and you should now be able to say that you can find the intersection points of quadratic and linear functions. All right, thanks.